Today we are talking about parallel lines and perpendicular lines and things we know when we have parallel lines that are being intersected by another line. We've got some vocabulary first. Parallel lines are coplanar lines that do not intersect. And our symbol for parallel lines is something that looks like a double L. When I write it, it might look like an 11. Our other symbol, when we are on a figure for parallel lines, are these arrows. Now this one set of arrows tells us that that set of lines are parallel to each other. A double set of arrows tells us that a different set of lines is parallel. So in our figure, line AB is parallel to line EF because they've got those arrows. Remember that if you are typing this, you would need to type a line and then a capital E and a capital F. Perpendicular lines intersect at 90-degree angles, so they intersect and form right angles. Our symbol when we write perpendicular is an upside down T. In the figure, it's this box in the corner. So if you don't have that box in the corner, don't tell me that it's 90 degrees. It's the only way you're going to know that something's 90 degrees today. Line AB is perpendicular with line EF in our figure. Or not EF, line AE, sorry. Because we have that box. Next up we have skew lines. So skew lines, they are not coplanar, they're not parallel, and they're not intersecting. So they basically have nothing to do with each other. They're not parallel to each other. They don't intersect each other. They're on different planes. So if we're looking at line AB, we could not say EF because it's parallel, or potentially CD or GH because we don't know for certain if they're parallel. And we can't say line BF or line AB because they're on the same plane with line AB. You also can't say line BD or line AC because they're on that back plane with line AB. What you could say is line EG. You could also say line FH. You could also say line DH. And you could also say line CG. Because they are not on the same plane, they are not parallel, and they don't intersect. Then we have parallel planes. Parallel planes are two planes that don't intersect. Remember that when you name a plane, you need to write the word plane in front and then 3 points that are on your plane, but not all on the same line. And when we are naming parallel planes, they need to be in the same order. So we've got plane ABE first. I'm going to go under it. So I've got plane C, D, and G. So C was under A, D was under B, and G is under C. Our next set of examples, we want to identify a pair of what's given to us in this next figure. First up, we're looking for skew segments. So we start with any segment. And remember that when we name a segment, you got to tell me that it's a segment. So I'm going to start with segment BC. And I want something that's not parallel to it, or potentially parallel to it, that doesn't intersect it, and is not on the same plane. So I could say segment EJ, or segment DH, or segment FJ, or segment GH. Again, notice that I wrote out the word segment, and my letters after it are capitalized because they're points on that segment. Next up, we are looking at perpendicular segments. So remember, perpendicular segments have to intersect and make a right angle. There's only one right angle symbol in this figure. It's right here. So that means there's only two segments that you know for certain right now are perpendicular. And that's segment BF and segment FJ. And our next example, we're looking at parallel planes. So remember, you need 3 points to name a plane. So I'm going to use this top plane and say a plane BCD. Remember that you need the word plane in front. And then I'm going to go under that plane to get the one that's parallel to it. Remember that we need to match up, so under B is F, under C is G, and under D is H. So we have plane SGH. Now somebody is probably asking why we used lines up here, why we named these lines and everything down here was a segment. The ones in this first picture all have arrows at the end, making them lines because they extend forever in two directions. In the figure below, none of these have arrows at the ends to show that they're lines. So they are just segments. They're part of a line. Next up, we are looking at parallel and non-parallel lines intersected by transversals. So a transversal is a line that intersects two other lines at two different points. So in our examples here, this line that goes through line R and S is our transversal, it's line T. And in our other example, this line here, line T again, that goes through line P and Q, is our transversal, because it's going through two or more other lines at different points. Now we're going to talk about some different angle pairs and things you know about them, specifically when the lines are parallel. You know a lot more about these angle pairs when the lines are parallel. Our first set is corresponding angles. You're going to have one exterior or outside angle and one interior or inside angle, and they're going to be on the same side of your transversal. So let's go over interior versus exterior when I'm talking about parallel lines and not parallel lines. So this part that is in between line R and S, the two lines that are getting intersected, is the interior. For the parallel example, it's what's in between lines P and Q. Everything outside of those lines is the exterior. So this is outside. Same thing happens on the non-parallel example. That's outside. So when we look and see which angles are corresponding, they've got to be on the same side of that transversal. One's outside and one's inside. So we'd have angle 1 and angle 5 being one set. Another set, one inside, one outside on the same side of the transversal, would be angle 3 and angle 7. Another set, one outside, one inside on the same side of the transversal. We've got angle 2 and angle 6. Next one inside, one outside, angle 4 and angle 8. So when you have two lines getting intersected by a transversal, corresponding angles are the only ones that have 4 sets of angle pairs. Now we do know more information when the lines are parallel, and we know that line P and line Q are parallel because they have these little arrows telling us that they're parallel. So our corresponding angles here, again, one outside, one inside on the same side of the transversal, would be angle 1 and angle 3. But because these lines are parallel, we know that angle 1 and angle 3 are congruent. Another set that would be congruent, because they're corresponding angles, are angle 2 and angle 4. Again, one inside, one outside on the same side of the transversal. Next up would be angle 5 and angle 7. Again, because you've got one outside, one inside on the same side of the transversal. Then we'd have angle 6 and angle 8. Again, because you've got one inside and one outside on the same side of the transversal. Alternate interior angles are going to be on different sides of your transversal, and they're both going to be inside, in between the two lines. They're both interior angles. So for alternate interior angles, we're looking in between our two lines that are getting intersected by our transversal, and we have one on one side, one on the other side. So we'd have angle 3 and angle 6. The other set would be angle 4 and angle 5. Now notice that these angles are using all 3 of those lines. And on this one, I've got a way that you can figure out if it's an alternate interior angle. if you trace your angles, it makes something that looks like a Z. On the parallel example, our alternate interior angles would be angle 2 and angle 7, and they are also congruent to each other. The other set would be angle 3 and angle 6, and they would be congruent to each other. And we only know that they're congruent when we have parallel lines being intersected. Then we have alternate exterior angles. Alternate exterior angles, again, they're on different sides of the transversal. That's what that alternate means. And this time, instead of both being inside, when we had the interior, we had exterior, so they're both on the outside. So different sides of your transversal, and they're both outside. In our non-parallel example, this would be angle 2 and angle 7. The other set would be angle 1 and angle 8. In our parallel example, again, different sides of your transversal and both outside angles. We have angle 1 and angle 8, and when we have parallel lines, we know that those angles are congruent. Our other set would be angle 4 and angle 5, and again, they'd be congruent because we have parallel lines. Our last one, same side interior angles, tells you exactly what it is. They're on the same side of your transversal and both inside. In our first non-parallel example, that'd be like angle 3 and angle 5. And the other set would be angle 4 and angle 6. And again, we know more information when we have parallel lines that are being intersected. We know same side interior angles are supplementary. They add up to 180 degrees. In our parallel example, the angles that would be same side interior angles are angle 2 and angle 3, and they would add together and equal 180 degrees. The other set would be angle 6 and angle 7, and again they'd add up and equal 180 degrees. Our next example, we want to name angle pairs and tell me which angles represent those angle pairs. So first one, we have corresponding angles. And our corresponding angles in this example, remember you have one outside, one inside on the same side of your transversal. Remember that in between is your interior, and not in between is your exterior. So our corresponding angles would be angle 1 and angle 3. Another set would be angle 2 and angle 4. Another set would be angle 5 and angle 7. And the last set would be angle 6 and angle 8. Then we're looking for alternate exterior angles. So remember, alternate exterior angles are on different sides of the transversal, and they're both on the outside. Our alternate exterior angles would be angle 1 and angle 8. The other set would be angle 4 and angle 5. Then we're looking for alternate interior angles. Alternate interior angles, remember, on different sides of the transversal, and both are inside. Our alternate interior angles for this picture would be angle 2 and angle 7. The other set would be angle 6 and angle 3. Then we're looking for same side interior angles. Remember, they're on the same side of the transversal, and they're both interior, they're both inside. So for this example, that would be angle 2 and angle 3, and the other set would be angle 6 and angle 7. So if you are typing this, you would need to type out the word angle, because there is no angle symbol. Our next example says identify the transversal and classify each angle pair. Our first example, we're looking at angle 1 and angle 5. Now, this over here is extra information for this first example. So I'd recommend covering it up with a sheet of paper, because it is likely going to confuse you if you don't. Now, look at what we have here. I traced angle 1 and angle 5. They are both on line N, so line N is our transversal. That means that they are between line L and line M, and they are both interior angles for this example, and they're on different sides of the transversal. And I know that they are interior angles because they are between line L and line M, the two lines that are getting intersected. So angles 1 and angle 5 are alternate interior angles. Next up, we are looking at angles 3 and 6. So those are the two that I just highlighted. And the line that they're both on is line M. That is our transversal. So again, if you need to, cover up this other piece with a piece of paper so it doesn't throw you off. Now, because line M is our transversal, that means that line N and line L are the two angles or the two lines, I mean, that we're looking at. And in between them is this area. So we have one interior angle and one exterior angle on the same side of the transversal. So that means that these are corresponding angles. Next up, we're looking at angles 1 and 4. So angles 1 and 4 are both on line L. So line L is our transversal. If you need to, cover this extra up. And then we're looking at these two angles, or these two lines, sorry. Everything in between them is interior, everything outside of them is exterior. Both of these are on different sides of our transversal, and they're outside of these two lines, so we have alternate exterior angles. Our last example here, we are looking at angles 2 and 5. These are both on line N. That means that line N is our transversal. And the two lines that we're looking between or outside of are lines L and M. Again, if you need to, cover up the extra. And these two angles are both in between line L and M, so they're interior angles on the same side of the transversal. That makes these same side interior angles. Things you might want to remember: all of your acute angles are congruent. All obtuse angles are congruent. And when you have one obtuse angle and one acute angle, those angles are supplementary when you have parallel lines being intersected by your transversal. That is only for when you have parallel lines. So our next example, we're looking at that 80 degrees and that X. So this is our transversal, and everything between the two lines that aren't our transversal is interior. So we have one interior angle and one exterior angle, and they're on the same side of the transversal. That means that we have corresponding angles. And remember that corresponding angles are congruent when we have parallel lines being intersected by a transversal. So that means that X equals 80. Next up, we're looking at that 125 and that X. And that means that this line here, line AF, is our transversal. Everything between the two other lines is interior. That 125 and that X are on different sides of the transversal, and they are exterior angles. So that means we have alternate exterior angles. And remember that alternate exterior angles are congruent when you have parallel lines being intersected by a transversal. So that means that X is 125. The next one, we're looking at 13x and 23x. They are both on line SU. And that means that our other two lines are the lines that are being intersected. Everything in between them is interior. So these two angles are both interior and they're on the same side of the transversal. So these are same side interior angles. And because they're same side interior angles, we know that they add up to equal 180 degrees. So that's what we're going to do. We're going to add 13x plus 23x, set it equal to 180. Then we're going to combine our like terms. So we have 36x equals 180. And then we're going to divide by 36 on both sides. And when we divide by 36, we get that x equals 5. Next up, we've got 2x minus 45 and x plus 30. Our transversal is line DE. Everything between the two other lines is our interior. So we have one interior angle, one exterior angle. On the same side of the transversal, that means we've got corresponding angles. And because we have corresponding angles, we know that those two angles are congruent and we can set them equal to each other. So 2x minus 45 equals x plus 30. Then we can subtract x from both sides. So x minus 45 equals 30. And we can add 45 to both sides, which means that x equals 75. And last one on the notes, we've got 2x plus 10 and 3x minus 15. Our transversal is line BD, and that means that everything between the two other lines is our interior. These two angles are on different sides of our transversal, and they are interior angles. So we have alternate interior angles. And we know that alternate interior angles, when we have parallel lines, are congruent. So we can set these equal to each other. So 2x plus 10 equals 3x minus 15. Then we can subtract 2x from both sides. So 10 equals x minus 15. And we can add 15 to both sides. So 25 equals